A customer sent in this power supply board from a Samsung Plasma TV for us to fix. The customer stated that they actually purchased it on eBay as a working board, but when they plugged it into their TV set, the TV had a loud pop and then there was no power. So let's take a closer look and see what we need to do to fix it. The first thing I'm going to notice with this power supply board is I actually have physical damage over here on the top right corner. If we flip it over, we can see there is a crack in the board. So we actually have 1, 2, 3, 4, 5, 6, 7, 8, 9 traces that are damaged and that will need to be repaired. But there was a loud pop, and I don't think this is a part of the pop. I'm also not sure if this damage occurred before the customer sent in the board for repair or if it occurred after the pop and during the transportation when we got it. I'm going to use my multimeter in continuity mode, so when we have a short, we have a beep. First thing I'm going to check is my fuse over here. And I do have continuity, which is good. I have another fuse over here. We also have continuity, so that's good. Let's flip the board over, and I'm going to check the 2 transistors over here. No short, no short, no short, no short. That's good. And let's check these guys. We do have a short. So these 2 transistors are shorted. That's going to be these 2 guys right here. So I did notice something which is strange on the first 2 transistors, and that is that this transistor and this transistor are not installed properly. The middle leg is not actually coming out of this pin, but through this hole. I'm not very comfortable with this. If someone did a repair like this, that means there's a good chance that the transistor they installed could be also incorrect if the installation was done incorrectly. So to be sure that our repairs are going to last, we're going to both replace the 2 shorted transistors as well as the 2 non-shorted transistors in case they are the incorrect kind of transistors. We're going to start by desoldering and removing the non-shorted transistors that were installed incorrectly. So now on the top side, we're going to go ahead and unscrew them. And now using the needle nose pliers, we should be able to get them out of there. So the transistors that were installed are FQPF20N60C. So that is a, I believe, 20 amp, 600 volts N-channel MOSFET, which is actually correct. So these guys are probably fine. We're still going to replace them with our own, just because I want to be sure that this repair lasts. But technically, we probably don't need to. Now, to make it easier for myself, I'm going to remove this silicone so we can see what we're working with. We'll do the same over here. And there's a few more components in the way, so this one's going to be a little harder. All right, and there's definitely a little bit of solder left in that center hole, so we're going to go ahead and use the desolder wick to remove the rest. We'll do the same to the other joints. There we go. Going to give that a quick cleanup. And we're also going to clean off the thermal paste on the heatsink. Again, I think it was probably fine, but I just want to be sure and put our own stuff that I trust. All right, we've now cleared off the 2 transistors. Before we install the replacements, we're going to go ahead and check out the other 2 that are shorted. Now, if we take a closer look, I believe the reason these shorted out is due to cracked solder joints. So it looks like we have a ring across and around both of those legs. And it looks like someone touched up this one over here. So that looks reflowed. Now if we take a look at this one over here, it does look like it was touched up as well, but not very well, and more specifically because of this joint right here. So the reason I say that is, as you can tell, if we zoom in a lot, there is some new solder here, but it is sitting on top of the old existing solder. So it didn't actually reform the bond with the PCB, it just added fresh solder to the tip of the pin without reforming a good bond. It looks like this joint over here was not touched up. And again, we also don't have good flow throughout the PCB to the pin right here. So I think we're going to have to touch that up again and redo it. So let's start with removing the shorted transistors. I'm going to add some new fresh solder first. I'm having a hard time getting all of that solder out, so we're going to try and finish that off with the desolder wick. I don't think I was successful. Alright, I have movement on all 3 pins. That means I was successful. Let's go ahead and tackle this one next. All right, let's see. We have movement here. Some movement here, but it's very stiff, so I think it's still perhaps soldered. And this one is free moving. Okay, so there's a chance this one is maybe not completely desoldered. We're gonna go ahead and try to remove them anyways, so let's get the screws out. All right, same thing. Let's go ahead and remove the transistor. So because this one's original, it's not as loose as the prior one. It is encased in that silicone. So actually it might be better to try and loosen it up first. And there we go. All right, so we're gonna go ahead and install our replacements. We're adding some thermal paste. All right, now we can go ahead and solder in our new transistors. And then just to clarify, we did put 20 amp, 600 volt N-channel MOSFET as replacements. All right, next step is our fuse, and it looks like someone has already replaced it in the past, but since it's blown, we're gonna need to replace it again. Okay, and it just fell. Per the board, it is a 10 amp, 250 volt fuse. Okay, we're gonna put our replacement in. Okay, we have a lot of leads to cut off now. And we did discuss this area, so we're going to go ahead and just reflow it. I don't think we need to do any replacement of any sort. So we're just going to add some flux, and then we're going to reflow everything. All right, and if we zoom in a little bit more, we can tell that these joints look a lot better. So I'm going to do a quick little inspection. There's always a couple other areas that get cracked solder joints on these boards, and often it's the components that share pads with the transistors we replaced. So for example, this capacitor here sometimes gets a cracked solder joint. Same with this one. Just going to give it a quick little reflow. This one right over here looks like it's a little heat stress and has the beginnings of a ring, so a crack. Reflow this. There we go. Everything else over here looks okay. That looks okay. That looks like it was worked on. Let's go ahead and touch that up. Actually, I'm not a big fan of how that solder flowed at all, so let's go ahead and remove it. Give that a quick clean. And now we can go ahead and add some fresh solder to it. That looks a lot better. Something I did not mention is when QS802 and QS804 fail, often what can happen is DS810 over here, this diode, and DS808 over here, they won't short out, they won't get damaged in a way that's detectable, but they will be damaged. And if I don't replace them now, there's a good chance that the diodes will short out, and once they do, they will cause QS802 and QS804 to fail again. So because I don't want to take that risk, I'm going to go ahead and replace them right away. And I did accidentally take a little bit of that solder off, so we're going to add it back. We're going to add a little solder to one side only. And we're going to slide in our replacement. Same over here. And on occasion, RS833 can burn up, so let's go ahead and do a quick measurement on it. So we're getting 46.9 ohms, and it is a 47 ohm resistor. Let's do the same over here. And we're getting 47 ohms. Perfect. Now, that has not completed our repairs yet because we do have that physical damage on the corner over here. So that's going to be what we tackle next. Now the board does not look like it's cracked all the way through. Well, it is cracked for the most part, but I don't think we need to do anything too fancy. We are going to remove the coating to make sure that the copper is intact over here. And it looks like it is. Let's see, this second trace over here looks like it's definitely cracked. So we'll have to rebuild this one. Okay, and it looks like this one is intact. It goes around and picks up back here. Okay, let's see. So it looks like the crack goes here and then finally breaks this copper trace over here. Okay. Oh, okay, I see. There's two traces here. All right, well, to rebuild these traces, we can start by bridging them. All right, so that should, in theory, fix our circuit board. All right, so we have our multimeter set to DC mode. We're going to go ahead and plug in the power supply. And we're going to do a quick check on our filter capacitors here. And we're getting 165 volts DC. That means that the board is currently in standby. So to activate it, we're going to need to short our PS on line here to ground. And I just heard it click. Let's take a look. And now we're getting 392 volts DC. So it is activated, which means we should now also get our 15 volt line, which is over here, which we do get. And of course, our 5 volt line will be on, and we do have that. Now, our VS and VA should not be active yet. And they are not. We're getting 0 volts here. To activate those, we're going to go to the VS on pin, and we're going to short that to our 5 volt line. And now let's redo a measurement. And our VS is now active at 221 volts. Let's check the VA, and we are at 55 volts DC. Both of those are good readings, and that does confirm that we now have a fully functional power supply. So that will confirm we have a successful repair. If you have a power supply that you would like to send in for us to fix, we'll have links to our repair services in the video description down below, as well as our contact form. Otherwise, if you found the video helpful or useful, make sure to leave us a like, subscribe for more content, and thank you for watching.